Okay, so ideal gases have no volume. Real gases do. That's why these don't exist. Okay, so ideal gases have no volume. Now this gives you 3 stars here.
Whoa.
This is Avogadro's law, or Avogadro's hypothesis. His theory. He says 2 different samples of a gas with the same temperature, pressure, and volume will have the same number of particles. So that's Avogadro's theory / hypothesis. Hold on a second. I want to make sure I'm not forgetting something. Okay. So what does this mean? Well, let me draw a picture here. So draw 2 containers. One has neon in it, and the other one, they're about the same size. They're supposed to be the same size. My drawing's not that great. Let's say you have 1 liter of each gas inside each box. 1 liter of neon, 1 liter of hydrogen. Let's say they're at STP. What does that mean?
Standard temperature.
Standard temperature and pressure. So that's 273 K. That's your temperature. Who remembers standard pressure?
1 ATP.
1 ATM. Or what's the other one? The KPA one.
Oh.
101.3 kPa. So we have the same temperature, the same pressure, the same volume. What this statement means is that however many particles are in neon's box, there's an identical number of particles in the hydrogen box. That's what that means. So if there's 1,000,000 particles in here, there's 1,000,000 particles in here. The analogy I use with this is kind of what they showed a little bit for a different concept, but soda. If you have 2 liters of Coke and 2 liters of Pepsi, you don't have more or less of either soda. You have the exact same amount. Why? Because you have the same volume. Gases, stay with me. Gases, you need the same volume, same temp, same pressure. It should make sense to you. If you have the exact same amount of both, you have the exact same amount of both. That's all this is saying. You have the exact same numbers. What does that mean? Temperature, pressure, volume. Then you'll have the exact same number of particles. The confusing part here is neon, when you draw a particle diagram, looks like that. Hydrogen looks like that. It's diatomic. So I use the word particle. I don't use the word atom or molecule. Why? That's an atom, that's a molecule. So technically, which one has more atoms?
Hydrogen.
Hydrogen would have twice as many atoms. So we don't say atoms. We don't say molecules, we say particles. That's a particle and that's a particle. So if this box had 10 million atoms, this box had 10 million molecules, they have the same number of particles. So that's why we use the word particle. It kind of covers both of those concepts. The other thing I want to mention about this from the video, Avogadro's number. Avogadro's number, and that number is 1 mole of any substance takes up 6.022 times 10 to the 23rd, has that many particles. You don't need to memorize it, but I'm giving it to you because it's a really important number in chemistry. You use it all the time in any level above regents. Okay, we will use it a little bit, but it's not going to be on the regents. So it's a really important number. That's why today's mole day. So that's Avogadro's number. How does that relate to something you do need to know? 1 mole of any gas, 22.4 liters at STP. This is something you need to memorize. It's not on your reference table, and the Regents expects you to know it. So not only did he come up with that number, he also came up with this. 1 mole of any gas takes up 22.4 liters as long as we're at STP. And that's it. That was going to ring real soon. So Monday we will start calculations using the gas laws. And that was it.